Hello there, everyone, and welcome to Limits Day 2. So hopefully you already listened to the notes about limits and what they are, and you did the review and the practice and all of that, and you're getting kind of good at it. Today is going to deal with limits as well. These will be short notes. This will not take a very long time. But today deals with end behavior. Now, when you were in Algebra 2, you talked about end behavior. You just talked about graphs like if they were an even degree, like x squared, then we knew that both ends were either pointing up if it was positive or pointing down if it was negative, like a parabola. And then if the degree were odd, one would be pointing up and one would be pointing down, again, depending if it was positive or negative. But now we are going to be dealing with end behavior in limits. But the definition for end behavior is how a graph behaves for very large or very small values of x. So we're talking about the ends of the graph. If you could extend your graph to where x is 1,000,000 and negative 1,000,000 to the left and to the right, we're extending it to really, really big values of x or really, really small value of x. What would your graph be doing? Now, always when we look at graphs, it's always centered on the origin and the y-axis and all of that. But we're not going to be focusing on that at all. We're going to be focusing on the ends. And we're going to do this with two different limits. So the limits that we're going to be looking at are the limit as x approaches infinity. So that's to the right. So that's as x is going to the right, as it moves moving towards infinity, what's happening with my y values? Remember, y values are what limits equal, so we're always looking for y here. And the other limit we're going to look for is as x goes to negative infinity. So this is going to be to the left. So again, as the graph, as x is going towards negative infinity, so really small values of x, what's happening with y? And today's problems are all just going to be from graphs. So for all three of these graphs, I just want to know those two limits that we just talked about. So the limit as x approaches infinity and the limit as x approaches negative infinity. So we want to find those limits for all three. So again, we don't care what's happening here in the middle. None of this matters. All that matters is what's happening on the ends. If I were to extend this to the right as far as I could, this piece of the graph would keep going up and up and up forever. It would be somewhere, if I could extend my computer somehow, it would be way up here and it would just keep going up and up and up and up. Okay, so as x goes to the right, my graph, my y values are going towards positive infinity. As my graph is going to the left, so as I'm going this way, what's happening to my y values? Well, they're also going up. So both are going towards positive infinity. Now for my next one, this is going to show you that your answers are not always infinity. So again, I don't care what's happening here in the middle. I only care what's happening as it goes to the right. So as it's going to the right, this actually looks like it's going to level off and it's just going to stay at 0. Same thing to the left. It's also going to be to 0. Okay, it's going to the left. It's just going to keep getting closer and closer to 0. That's a horizontal asymptote. So both of those are 0. Now they don't always have to match. I can see on this one, my two ends of my graph are doing two very different things. So as my graph goes to the right, it looks like it's leveling off here and it's going to stop at 3. But to the left, my graph, my y values are going way down and they're going to keep going down, 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 down. So they look like they're going to be at negative infinity. Oh, that's a terrible infinity. Okay, so they don't have to match your two ends. And again, you don't need this middle part. You only care what's happening to the very right and the very left. So if you want to try these next three on your own, pause the video, try them, and then come back and see if you did it right. You can, or you can just keep following along. But again, I'm only going to write these limits 3 times just because it's kind of tough to write on the screen. Okay, so again, to the right and to the left. So my first graph here is just a line. As my graph moves to the right, my y values are going towards negative infinity. And as my graph goes to the left, those are going towards positive infinity. Here, moving to the right, my graph is going towards positive infinity, and to the left, my graph is moving towards 0. Again, these are always y values. And here for my third one, what are my y values doing? Well, they're both going to infinity. Now, just a little side note, something that I should have done here. Let's just say, for argument's sake, that this was a dot. Let's say it stopped there. It wasn't an arrow. If that was the case, if it stopped there, then this limit, as we're going to the left, wouldn't exist. And that's because my graph stops. There is no limit. So if I'm going over here way to where, like I said, x is like negative a million, there would be no graph. So if the graph stops at any point and does not continue on to the left or to the right, then that limit wouldn't exist because there isn't an end behavior to speak of. So I just wanted to throw that in there. Okay, our last slide here. Again, if you want to try this one on your own, pause the video, see how you do, check your answers, great. If not, you can just stay with me and we'll do these last. Let's do pink. We'll do these last 3 here. So the limit as x approaches infinity and the limit as x approaches negative infinity. So again, these first two here usually trick people up. Okay, but again, I don't care what's happening here. None of that matters. It only matters to the very right and to the very left. So to the right, the graph is going towards negative infinity, and to the left, the graph is going towards 0. For my middle one here, again, I don't care about what's happening here. To the right, my y value is going towards -6, and it's just going to stay on -6. And to the left, my graph's going towards infinity. And finally, my last graph here. Again, I don't care what's happening here. To the right, my graph's going towards negative infinity. And to the left, my graph is going towards positive infinity. And I apologize for that horrific infinity symbol there. Oh, it erased everything. Well, we'll just do it again. Let's see. Here we go. Towards negative infinity and positive infinity. Okay, so your homework here is just a few problems. They give you a bunch of directions. You only have to find these 2 limits. That's all that we care about here for end behavior. Just remember that end behavior, and this is the big key, this is what everybody forgets, is that end behavior, that just means you're finding these 2 limits. That's all that means. Every time you're finding those 2 limits, no matter what the graph looks like, that's what that means. So anytime you see end behavior, you should think I'm going to infinity and towards negative infinity. Okay, so go ahead and try that homework. I'll be posting it online as soon as I'm posting these videos, so it'll be there when you see this video. Again, just hopefully you're trying this on your own. If you need to get the book online, all the information is on the Classroom. You'll probably have to scroll way down to the bottom of the stream at the very beginning of the year. There's a link for the textbook, and there's the code is on the syllabus. So you'll have to find the syllabus and the code and your link to the McGraw-Hill textbook. You can get the whole thing online if you haven't been doing it so far this year. So if you're having any trouble getting on the textbook, you just use your Greater Latrobe login information. So your email and your lunch account or whatever, it's all the same. Log in, use the code to get the book, and you should be able to see the book there if you don't have a physical textbook at home with you. Okay, don't forget to stop in during my office hours. you can stop in just to say hi. But good luck with all of this. Let me know if you're having any troubles.